Good morning. Today me and my team of expert project management specialists will be talking to you about linear programming and its use in critical path analysis. Linear programming is an optimization tool used to maximize and minimize functions. For example, maximizing profits or minimizing costs. We will talk about how to use it in critical path analysis and how to apply that technique on Excel. Its basic structure is to maximize or minimize an objective function while satisfying set constraints. Project managers often find themselves in situations where they have to determine the level to operate each activity in a project. It's an easy tool to use on a large set of data, and its major advantage is its ability to be controlled in the implementation stage.
So now I'm going to talk about one case study of how to apply the linear program to find the critical path. So we are assuming that we are going to build a building of the textile industry, and there are several activities that we need to complete, and our objective is to finish the project, to minimize the time of finishing the project, and the constraint is that each activity needs to have a fixed duration, and there are precedence relationship among the activities. That is to say, we cannot go backwards in time. So firstly, let's draw a project network. So assuming that this is our starting point and this is our finish point, and this is time 0. Building the foundation is the first step of the building. So this is time 1, and after building our foundation, we can begin to build our walls and ceilings. So this is time 2, and we can see from the table that we can building our roof, do electrical wiring, and putting in the windows at the same time. So there are CDE is followed by activity B. But however, there are some predecessors that is activity F is followed by E, and activity G is followed by C and F. So it is something like, so this is time 3, and F is followed by activity E, and after finishing C and F, which is time 4, we can start our activity G. But we can see from the table that D is followed by activity D is followed by B, but there is no activities that followed by D, so D is directly to the finishing point, which is time 5. So this is our draft of our project network, and then let's demonstrate how to use the Excel software to find the critical path.
Yes. And then I will talk about how to use the linear programming to find a critical path. First, we need to find the decision variable T0 to T5, and we just type 0 at T0, 1 at T1, and so on. Then we need to let G3 to equal G6. Define T1 to be the time at which node I occur, at which time all activities preceding node I have been complete. Define T0 to be 0. Here is spreadsheet model. The matrix of 0, 1, and -1, B12, G18 are one way to set constraints. The sum product function in H12, H18 calculates the elapsed time between related node pairs corresponding to various activities. The duration of the activity is shown in J12 and J18. When you're working with a spreadsheet model, you are going to need basically 4 things to be in order to formulate something that the solver can actually solve. So we are going to need an objective function, and the objective function is the thing that we are trying to maximize or in some case minimize. So the objective here is our complete days G3. You can see that default is maximizing that, but you also have the option to minimize or set it at a specific value. Second thing that these models are going to need is input variables, so some kind of resource that are going to be used. They have decision variables or how many to make or how to allocate. So I will point, click, and drag on this. And then they all have constraints, all constraints being bigger than or equal to duration values. Let's click add. I'm going to point, click, and drag those and change it to big than and equal to, and point, click, and drag, and then click OK. After finish all steps, click solve. A few seconds it will give us a solution, and this is the message we are looking for solvers. We have used the Excel conditional formatting feature here to identify the activities on critical paths. We just use the highlight cell rules and click equal. So the project will take 26 days to complete. The only activity that is not critical is the activity D.
This is Winfried. In summary, linear programming is a useful tool for project management. Generally, the real relationships may be more complicated. By using linear programming model, we can reduce them to linear relations, and then find the optimal solution. In addition to critical paths in project management, linear programming model can be used in many fields and our real life, like diet problem, transportation, telecommunication. These are our references. This video ends here. Thanks for watching.